Alright, geometry, here's a video on 2.5 notes. So to start, we're going to look at these proof starters and kind of see where this gets us. If they give you something, a statement, you're trying to figure out what to do with that information. So to start, they tell you that B is between A and C. We don't know if it's in the middle exactly, but we just know it's between those 2 points somewhere. If they ever give you that information, you can set up a segment addition where A, B plus BC equals AC. That's segment addition. Trying the next one, they give you a midpoint, which means that T is definitely in the middle of SU. If they give you a midpoint, you know that those little segments are congruent to each other. So you can say ST is congruent to TU. That would be definition of midpoint. If they give you a segment bisector, they tell you that XY is being bisected by VW at point T. That means T is perfectly in the middle of XY, which means XT is congruent to TY. That would be definition of a segment bisector. Okay. In every proof, you need to start by writing the given. So we will do that here. AB, oops, there's something else first. It says B is between A and C. AB equals 2x minus 1. BC equals 3x plus 5. And AC equals 19. That's given. Our job is to set something up to be able to show that x equals 3. We don't know x equals 3, that's just where we're headed. They gave us that B is between A and C. We can set up segment addition where AB plus BC equals AC. We know that AB is 2x minus 1, and that BC is 3x plus 5, and that AC is 19. So we can write 2x minus 1 plus 3x plus 5 equals 19 using substitution. From here, when I combine like terms, I get 5x plus 4 equals 19. Anytime you simplify, that's substitution. I will subtract 4 and get 5x equals 15. And then when I divide by 5 for division, I get x equals 3, which is substitution. Since that's what we were looking to get, we're all done. Let's try the next one. They tell me that E is the midpoint of DF. They tell me DE is equal to 5x plus 1, and EF is equal to 4x plus 5. All of those are given. When I look at my proof starters, it's helpful to realize and remember that if they give me a midpoint, that means that you've got two equal pieces. So DE is congruent or equal to EF because it's a midpoint. So definition of midpoint. DE is 5x plus 1. EF is 4x plus 5. That would be substitution. From here, we'll solve. So subtract 4x. That would be subtraction. And you get x plus 1 equals 5. That's substitution. Subtract 1 to the other side, and you get x equals 4. It feels like we're done, but is x equals 4 what they're wanting us to prove? Of course not. We need to go one more step. I know so far that DE is 5x plus 1, but I now know that x is 4. So 5 times 4 plus 1 with substitution allows me to say that DE is going to be 21 when I simplify. It's not always the case that your final answer, your final reason is going to be substitution, but it does happen a lot because substitution is used anytime you simplify. This next one says that A, B, and DE are congruent. That's your given, and I marked it on my picture with a little tick mark. Now, I don't know anything based on that, but sometimes I like to look ahead. Where am I going? I'm going to try to find that CD plus AB equals CE, and currently I don't know anything about the length CE. I could set up segment addition and say that CD plus DE equals CE. Okay. And from there, I've seen DE before. DE is the same as AB. So I could say CD plus AB equals CE, which is substitution. And that's actually what they wanted us to find. So we're all finished with that one. On the next one, you'll start with your given. G is the midpoint of FH, as well as FG is congruent to HI. Those are both given. If G is the midpoint of FH, I would be able to say that FG is congruent to GH. That's definition of midpoint. Notice that they said that FG is congruent to HI and FG is congruent to GH. That would mean that GH would have to be congruent to HI together. That would be substitution. That's actually what they're wanting us to get, so we're all finished with that one as well. This next one's the longest one on our notes. I want you to start by writing the given. JK is congruent to MN, and KL is congruent to LM. I'm also going to put that on my picture with little tick marks. My goal on this one is to say that L is the midpoint of JN. That would be the last line. If L is the middle of JN, that would mean that JL and LN are the same. It would be ideal if I could end up with that information, but when I look at this, JL, I currently have no information on JL. So it would be helpful if I tried to get some. Well, JL, I could set up segment addition, would be JK plus KL. We can say the same about LN. We currently don't know any information about LN, but I could set up that LN is equal to LM plus MN. Those are both segment addition. Now I have seen JK before. Over here we had that JK and MN were the same, and I have seen KL before. We had that KL and LM were the same. I'm going to rewrite JL and substitute those pieces in. So instead of JK, I'll have MN, and instead of KL, I'll have LM. That would be substitution. From there, I noticed that these two are very similar. They're very close to each other. I have LM plus MN, and I also have MN plus LM. When you are adding, it doesn't matter what order you're adding. So I can even rewrite JL to be LM plus MN. That's the commutative property of addition, where it doesn't matter what order you add things in. Now when I compare LN and JL, they're exactly the same. If they're exactly the same, you can set them equal to each other, which would be substitution. And if JL is equal to LN, that means that L would have to be smack dab in the middle. So I can say that L is the midpoint of JN using definition of midpoint. Okay, on to our last one. They did give us that RT is congruent to SU. When I look at my picture, RT and SU are very different. Now we know they're congruent, but I could say that RT is RS plus ST. I could say that SU is ST plus TU. Those are both segment addition. We just said that those are the same. So if RT or RS plus ST is supposed to be equal or congruent to SU, which is ST plus TU, using substitution, you can say RS plus ST equals ST plus TU. From here, I want to solve, and look what we're trying to get. RS is congruent to TU. If we subtract ST and get it out of the way, I could say that RS is equal to TU. So that would be subtraction and then substitution. From here, we technically have what we need. In some levels of geometry, they will take that RS is congruent to TU is a little bit different than RS is equal to TU. To change it to a congruent symbol, you would just use the definition of congruence. That step is optional for our class. So you can leave it as RS is equal to TU. All right, that is your last proof for 2.5. Good luck on your homework.